Good day everyone, especially to our subject instructor in CS 223, Mr. Renan Amugis. I am Jhobert A Olaivar from the Group 8. So our topic for today is all about language specifications. So what is language specifications? It is a formal language in computer science, is used during system analysis, requirements analysis, and system design. It describes a system at much higher level than the programming language used to produce the system's executable code. Generally, not directly executed, meant to describe the what and not the how. Next, languages. Natural and computer languages. Syntax, cinematics, and pragmatics are categorized descriptions of language characteristics. In English, syntax refers to the way words and sentences are placed, follows subject-verb agreement. Cinematics, understand the meaning. For example, John prepared the dishes, Jane washed the dishes. Context 1. All the workers in the restaurant performed their duties. On 20 May, John prepared the dishes and Jane washed the dishes. Context 2. The couple prepared dinner on 21 May 2009. John prepared the dishes and Jane washed the dishes. The fancy term for this contexting is the pragmatics of the language. All syntax, cinematics, and pragmatics are required to convey the whole message. Programming languages. In programming languages, syntax is a set of rules that defines the combination of symbols valid in a given language, expressions, statements, and program units. For example, if you put bar before the word, that word becomes a variable. The word that you put after the bar shouldn't be one of the JavaScript's reserved words. You can assign values with a single equal sign. You can also subtract using the minus sign. Next, cinematics. The meaning of the sentence constructed by putting together some valid syntax. Meaning of those expression statements, the program units. For example, plus is a valid syntax for the plus operator. But if you type x plus 1 in a JavaScript program and run it, it will give you an error. So, x is the valid syntax. Thus, plus is the valid syntax or 1 is the valid syntax. For this, my explanation is JavaScript will give you an error because the x doesn't have a numerical value. Next, pragmatics. Pragmatics is a way in which the language features are used to build effective programs. Diving deep into the core concept of programming, for example, what is a variable scope and how can you use it in your programs? What are the closure and how can you use them in your programs? When do you use arrow functions and when do you use classic functions? General problem of describing syntax. Language. Natural like English, artificial like C, Java, and etc. Set of strings of characters from the some alphabet, sentence statements, a string of language. Syntax rules of language specify which strings characters from the language alphabet are in the language. Terminologies. Lexicon. Lexicon is a set of grammatical categories in a language. Defines legal tokens. Tokens. A particular syntactic unit from a particular grammatical category. Lexemes. Lowest level of Syntactic unit of a language. Lexemes, the smallest unit of language, includes numerical literals, operators, and special words, partitioned into groups and each represented by token, a category of its lexemes. For example, name of variables, methods, classes. Another example, index equals 2 times count plus 17, semicolon. So here are the tables that includes lexemes and tokens. In lexemes, equals sign is a symbol, while in the tokens it is a word, which is equal sign. Index is considered as identifier in tokens. 2 is considered as int literal. Times is considered as multi-operator. Count is considered as identifier. Plus is considered as plus operator. 17 is considered as int literals, and semicolon is considered as semicolon. Next, distinct ways in defining a language. Language recognizers. It is recognition device reads input strings of language and decides whether input strings belongs to the language. It is also a syntax analyzer. Language generators generate sentence of a language. People prefer certain forms of generator over recognizer because they can more easily read and understand them. So, so the language generators are more preferable than language recognizers. Next, formal methods of describing syntax. Grammars commonly used to describe the syntax of programming languages. It is a formal language generation mechanism. Language of all language. Backus Naur form and context-free grammars is Noam Chomsky and John Backus middle to late 1950s developed the same syntax description formalism and most widely used method from programming language syntax. And lastly, extended BNF.
Good day, I'm Evangeline Tinaco and I'm here to continue the report of context-free grammars. The context-free grammars made 1950s Chomsky and not linguist four classes of generative devices. Four grammars that define four classes of language recursively enumerable grammars: context-sensitive, context-free, and regular. Number 1. A context-free and regular. To useful for describing the syntax of programming language. Second, regular grammars can describe forms of the tokens of programming language. Third, syntax of whole programming language with minor exceptions can be described by context-free grammars. To studied in fields of theoretical computer science, compiler design, and linguistics. To describe programming language and parser programs in compilers. Used to describe context-free language and to set of recursive rules used to generate patterns of strings. Describe all regular language and more, but they cannot describe all possible. 4 components. Terminal symbols, characters that appear in the language strings generated by the grammar always in the right hand of the side production rule. Second, non-terminal symbols of variables placeholders for patterns of terminal symbols that non-terminal symbols can generate always appear on the left side hand of the production rules. The third components, production of roles, which of the replacing non-terminal symbols to form a variable string of variables and terminals. Fourth, start symbol, which is a special non-terminal symbol that appears in the initial string generated by the grammar. Formal definition of context-free grammars. A context-free grammar can be described by a four-element tuple. V element R S where V is a finite set of variables which are non-terminal. Element is a finite set disjoint from V of terminal symbols. R is a set of production roles which production role maps are variable to a string. S which is and V which is a start symbol. Example. Verse 3. Derivation tree of concrete syntax tree is an ordered root tree representing the syntax structure of a string according to some context-free grammar. Ambiguity. Grammar implies that at least some strings in each language have different structures. Parse 3. Example. Backus-Naur form. Backus-Naur form, a formal mathematical way to specify context-free grammars. Unprecise and ambiguous. John Backus presented a new notation containing most of the elements of BNF at a UNESCO conference about Algol 58, and invented Fortran or Formula Translator is the first high-level language ever circa 1954. And Peter Naur read this report and found that he and Backus interpret Algol differently. Create we know now the BNF or Algol 60. And Danish astronomer turned computer scientist. And BNF are originally stood for Backus normal form or BNF. In 1964, Donald Knott wrote a letter published in Communication of the ECM which he suggests it stand of Backus-Naur from instead. First, recognize Naur's contribution. Second, BNF is not technically a normal form. This would imply that there would be only the one correct way of writing a grammar.
This is what a BNF look like.
So, good day everyone. I'm Charl Besinga and I'm here to continue the topic about language specification. So, extended BNF stands for Extended Bacchus Nor Form. After BNF appeared with Algorithm 60, lots of people added their own extensions. So, programming languages. Nicholas Worth wanted to see one form, so he published What Can We Do About the Unnecessary Diversity of Notation for Synthetic Definitions in Communication of the ACM in 1977. He suggested the use of brackets for optional symbols like 0 or 1 occurrences, curly brackets for 0 or more occurrences. So ABNF is a few simple extensions to BNF, making expressing grammars more convenient, adds synthetic sugar. Thus, it is more concise than BNF. EBNF is more powerful than BNF. That is, anything that can be expressed in EBNF can also be expressed in BNF. EBNF is widely used as the de facto standard to define programming languages. So what are the extensions? They vary but often are derived from regular expression syntax. The clean star means 0 or more occurrences. The clean cross means 1 or more occurrences. The question mark means 0 or 1 occurrences. Sometimes brackets used instead. Use of parentheses for grouping. So BNF versus EBNF. Grammar for decimal numbers in plain BNF. Example, expression con equals to negative num or num. Or num con equals to digits or digits or digits. Digits con equals to digits or digit to digits. Digit concons to equals to 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9. Same grammar in even if expression con equals to negative question mark digit, clean cross or digit, clean cross question mark. Digit con equals to 0, 1, 2 or 3 or 4 or 5 or 6 or 7 or 9. So much more concise. An optional negative 1 or more digits and an optional decimal point followed by 1 or more digits. Simple conversion. If you have such rule as expression con equals digits or digits con equals digit or digits to digits, you can replace it with expression con equals digit plus screen cross. If you have a rule such as expression con equals digits or empty, you can replace it with expression con equals digit to clean star. If you have such a rule as id equal con equals letter or id letter or id digit, you can replace it with id con equals letter or digit clean star. Names and bindings. Names are fundamental abstraction in languages to denote entities. Names allow us to reuse definition from the earlier point of the program, and they are characterized as a single definition and many uses as we would like. The definition is let pi equals 3.14. In pi times pi is used. A definition binds name to meaning. Meaning can be a value type or function. Valid names vary by language, caramel case, or foo, bar, or lips name. Names or identifiers denotes various language entities like constant variables, procedures and function types, etc. Entities have attributes. So example of cities is constant and example attributes are type or value. Next example is variables and the example attributes is are type and location. Functions. Example attributes are signature and implementation. Keywords and reserved words. Some name shaped words have special meaning. If, while, diff, return, or class. Reserved word, name with fixed purpose. Keyword, name with a fixed purpose only in some context. Fortran, so integer real, not integer variable real. Real integer, not floating point var integer. If equals to 7, not assigned to number to var if. So definitions and bindings. Bindings map names to attributes. Each definition introduces bindings. So as you can see in the tables below, in the C table, constant integer I equals to 3. So I type integer or I access to read only. I is a value of 3. So in the next table, the Haskell table, data T equals to A or B. So the T can be kind or option. Kind data to clean cross, and T options equals to A or B. The A is a kind of cons or A type T. B kind of cons also and type T. In binding time, bindings can happen at various times in program execution and even before program execution. So language definition equal minus time binding. Class binds to addition. So static binding Java string is type binding fixed string at compile time. In dynamic binding, si x equals to 2 semicolon. If y
Semicolon.
is greater than 1, x equal to 7 semicolon. Value binding changes at runtime. So key points. Names allow sharing of information. Definition binds names to attributes. Attributes contain many properties such as types, values, access rights. So definition can create bindings at various time like compile times, static binding, or runtime dynamic binding. That's all. Thank you.